convergence or divergence by using any test. So it kind of looks ugly at first, but I took out a -1, and it's in the form of A times R to the n, which is geometric. And so the ratio, the absolute value of the ratio is less than 1. So, and then I have to compute the bound, which is 1 over e plus 1. So it definitely converges. And the limit of the partial sum size as it goes to infinity is this formula here. So that's how you get the bound. Yeah, and if I do the nth term test, it would go to 0. And since it's alternating, we can actually do the alternating series test, I guess.
You could do the alternating series test. So let's see, you've got -1 to the n plus 1 over e to the n.
And then I took out -1 to the 1.
Right, to make it negative, the whole thing to the n.
And that's just a constant.
Which is just a constant, I agree. And it's still alternating, right?
Mm-hmm.
Is there a way to write it as, so that the a to the n part is always positive? You see what I mean?
Maybe, yeah.
You just put the n plus 1 on.
So now, and let me ask this, are you saying that that series converges to 1 over e plus 1?
Yes.
Even though it's alternating?
Yes.
I believe
Pretty
that.
sure. Oh.
See, I,
So if you take like the first term, right, and then the -1 squared, so that's just 1.
right.
And then e to the 1, we have 1 over e. And then the ratio is -1 over e. So that'll be positive. 1 minus the -1 over e. So that's e over e plus 1.
Okay, so I'm not saying you're right or wrong. I'm just saying I have to think about it, and I can't think sitting down. So I'm gonna come up here and take a look at it and see if I can figure it out. Let's all just look at what it is first, right? So the first thing, let's just look at some terms. What's the first term?
1 over e.
1 over e, right? What's the second term?
-1 over e.
Right? So what's the way to write it in standard form? I had just given you this on the test and said write this one in standard form for an alternating series. What's standard form for an alternating series? The an part always has to be positive. So how would I rewrite this? Yeah, -1 to some power, right? Okay?
And then 1 over e to the n.
Right. Okay, so there it is in standard form. Yeah.
Wait, was that negative sign supposed to be?
Let's see, she factored a negative, she's saying that -1 to the n plus 1 is equal to -1 times -1 to the n, right? Well, okay, so what she's saying is this.
Since it's alternating.
Yeah, it took me a few seconds to see it too. She has, oh, sorry, I just wrote it wrong. She has negative 1 to the n plus 1 over e to the n, right? That's the same as negative 1 to the 1 times negative 1 to the n over e to the n, right?
Okay.
That's the same as negative 1 over 1 times negative 1 over e
To the end.
to the n, right? So our algebra's okay. But I think she would agree, and you would agree, this is simpler, right? Looks simpler. Now, we've got this formula that says sum from n equals 0 to infinity of r to the n is 1 over 1 minus r, right? So I can, if I ignore this part, if I ignore that part, then the sum from n equals 1 to infinity of 1 over e to the n is the sum from n equals 0 to infinity of 1 over e to the n minus 1 over e to the 0, because I added the 0th term in and I'm subtracting it back out. That whole thing's 1. So that's 1 over 1 minus, the r is 1 over e, right? So I asked you, what does this one converge to? Simple problem on a test. We have a formula. If it had started at 0, so I adjust it so it starts at 0. Then I subtract off the 0th term. And apply my formula, 1 over 1 minus r. Now I'm going to have to do some algebra to simplify that and figure out what it is. Multiply the top and the bottom by e. E over e minus 1 minus 1. So that's minus e minus 1 over e minus 1 equals e minus plus 1 over e minus 1. E-I-E-I-O.
Did this problem start at 0? Like, why did that end 0?
Pardon?
Did it start at 0?
No, hers did not, but I was just looking back at the sum. If I was saying, what if I threw this out for the second? Let's just throw out the alternating part and see what we get for an answer. Just trying to learn something about the problem. So if I had started it at 1, then a way to evaluate it, it said my only formula starts at 0, is this.
Okay.
Now she knows that there's this formula that says that sum of a times r, sum of r to the n equals k to infinity is the first term divided by 1 minus r, a1 being the first term. And so that's the formula that she's using over here. And so since the first term starts at 1, and I've got something in the notes here later on that helps us compute these guys, but I don't have it memorized, so I don't remember it off the top of my head. Regardless, this is the one we wanted to solve, right? Now, how can I solve this one just to know whether it converges or diverges? Well, we could tackle it one of two ways. We could tackle it with the alternating series test, but we just proved that it's absolutely convergent, didn't we? We just proved that if I throw this away, it converges. That's what the absolute convergence test says. If you throw away this and it converges, then it still converges when that's there. So remember, by the absolute convergence test, since the sum of 1 over e to the n equals 1 to infinity, converges, which is what I did here, which is what you were asking for. Why did I do this? The absolute convergence test says if you throw this away and it converges, then it definitely converges with that there. So I'm pulling it out, showing that it converges using a formula. And somebody asked me earlier, I think Joseph asked me earlier, does it matter if this is n plus 1 or n minus 1? And it doesn't, because what happens is you're either doing plus minus, or you're doing minus plus minus plus. You can factor the negative out. So if it converges with there, it converges with a minus 1 or a plus 1, or whichever you want.
By putting an n or an n plus 1, like Chelsea did over here, can that change the actual
Convergence?
No, the first, you see how it's negative 1 to the 1 multiplied by negative 1 over e. And correct me if I'm wrong, but what happened was you put an n plus 1 on the outside, which turned the 1 over e to the positive term, right?
Yes.
So you can kind of interchange those to manipulate.
Yeah, because all our tests talk about the alternating part, n or n plus 1 or n minus 1. And the a to the n, where we're assuming that this part is positive. So I'm just rewriting it in standard form so that it fits the tests that are written down in the notes. That's all I'm doing, is rewriting it so it looks like one of the tests that's in the notes. And the test that's in the notes talk about this part being positive and this part being your alternating part. And what I was just saying is it doesn't matter n plus 1, n minus 1, because if you've got the sum from n equals 1 to infinity of negative 1, I mean, it affects what it is. That is, the first one's going to be positive. That's a1 minus a2 plus a3, dot, 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 right? But if you're, in the notes, it's this, is the problem you're looking at. Well, that's negative a1 plus a2 minus a3, dot, dot, dot.
What I'm trying to figure out is, say you have a negative an right there.
Mm-hmm.
Could you then just change the exponent, the negative 1 over n,
Sure.
to kind of fix it to where it is positive?
That's exactly what I do. I factor the negative out of here. Negative, now what do I have? I have the sum from n equals 1 to infinity of negative 1 to the n plus 1, 1 over 3 to the n. Now I've got geometric, just like that one. Throw this part away. It converges because it's geometric and r is 1/3, which is less than 1. Therefore, it certainly converges. The absolute convergence test says if it converges without the alternating part, then it definitely converges with the alternating part. And so now what we've figured out from this is just a bad way to write it. And now we've rewritten it nicely just using some algebra. And now we see the first term is positive. So it's 1/3 minus 1/9 plus 1/27 minus 181. Dot, dot, dot.
I cleared that up for me. Thank you.
That help? Other questions on this one? And when I'm sitting here, what I'm struggling to remember is that she's using the formula for a1 over 1 minus r, and I can't remember if that's okay if the alternating series test, I can't remember, I'm sorry, I don't know that that's valid when it alternates. I don't think it is. My gut feeling tells me it's not, but I can't swear that it's not. And when I checked over here, yours is believable because this 1 over 1.718 is bigger than what you got. Since we're subtracting every other term off, that makes sense. I know a way to check this, Chelsea. Since you're a master of these things series, you could rewrite it as the sum of the positive terms, because the positive terms are the odd terms, right? Like 1 over e to the 2k minus 1. minus the sum of the even terms. Oh, easy. Now you can figure out what both of these are using the geometric series test, being clever, and then you can figure out if that really equals what you got there. Okay? But the quickest way, if you're on a test and you're in a panic to figure this guy out, is to realize that's geometric, so the absolute convergence test guarantees that it converges.
Fix that one. Can I throw it back on the board? It shows what I finished that one. Can I or fix that one?
But well, I don't know if we'll have time to go over it today. Let's get the rest of them up because I seem to be talking a lot today. Who's next? 290.4. No, that one's done. 292.
My problem was the alternating series. -1 to the n over the cube root of n. I just basically broke it apart and had 1 over the cube root of n, and then I changed it to 1/3 to make it easier to work with. I tried to use the the absolute convergence test, and the test fails because it diverges by the limit comparison test.
Before you go on, when he takes the absolute value of that, what kind of series is he looking at? Look at the very first one, far right top.
Right here.
Right. What kind of series is that? If he takes the
P-series.
absolute value of it. P series with P
Less than 1.
less than 1.
Oh, that's
So-
why.
Right. So you know you did the limit comparison test with 1 over n, but you don't have to, right? Because you know right off the bat that's a P series. So the absolute convergence test doesn't help me.
So the next step was to do the alternating series test, and taking the absolute value of that. And the first part was to find out if all the terms are positive. So I set this greater than 0, and 1 is greater than 0. So that's a true statement. The next step was to find out if the series was decreasing or non-increasing. So I did 1 over n plus 1 to the 1/3 less than or equal to 1 over n to the 1/3, and that's a true statement because 0 is less than or equal to 1.
Cross multiply that and write it down for me again. What do you
Okay.
get? Uh-huh.
Going from here.
Yeah, but I don't know how you got the n to the 1/3 plus 1 over there.
Right here. I just did n to the 1/3 plus 1 to the 1/3.
Is x plus y squared equal to x squared plus y squared?
I'll say that one more time.
Is x plus y in parentheses squared
Uh-huh.
equal to x squared plus y squared?
No.
No, so n plus 1 to the 1/3 probably isn't equal to n to the 1/3 plus 1 to the 1/3.
Okay.
So just put it in parentheses. Put that
This.
on the right side. Make it n plus 1 all to the 1/3. Now take the cube root of both sides.
Both sides of this.
And what do you have? N less than or equal to n plus 1. And now you do get 0 less than or equal to 1, right? 0 less than or equal
Okay, so still correct.
to 1. Okay.
And then the next part of the alternating series is to take the limit of the absolute value, right? The limit of the absolute value, and the bottle's going to infinity, so the whole thing goes to 0. And by the alternating series test, this series is conditionally convergent because the whole series is divergent, but the absolute value of it is convergent.
Questions for him? A good example of the absolute convergence. Tyron, don't worry.
I mean, I see LCT.
Oh, that was the limit compare. I did the limit. I didn't write it out, but whenever I first tried to do the absolute convergence, yeah, I just wrote it on here. But like when I did it, I did the limit comparison test and it diverged. But also, it's a P series, so I didn't even really need to do that. You can just look at it and tell.
Why does the absolute convergence test fail?
Huh?
Why does the absolute convergence test fail?
Because it doesn't converge.
So it has to.
Right, the absolute convergence test says if you throw out the alternating part, and that converges, then it converges when you put the alternating parts back in. So, but if he throws out the alternating part, he's got a P series with P less than 1, so we know that guy diverges. So that test doesn't help him. And he said he did it with a limit comparison test. I'm just saying that you can, but you don't have to, because you just claim, I know, I've memorized my P series test. Okay? Was that all of them? Did we get them all? No, Gerardo's got one of them. Gerardo. Oh, our first ratio test.